Whoa, there is a lot of people. I wasn't expecting to be like that. So hello, everyone. I'm Albert Franzi. I came from Schibsted, a company that owns different media houses and marketplaces around the world. And I will talking about how to modularize your Spark code into pieces. First of all, I would like to share my slides. So if you want to go back to any slide that I was talking about, so you can just go in your laptops, and so you can pay more attention instead of taking a lot of photos during the talk. However, if you want to take some photos for Twitter, feel free. So I will wait just a few seconds for that. Okay, perfect. So let's follow. I would like to introduce myself. I started my data journey more or less 5 years ago at Trovit. Trovit is a search engine company with marketplaces based in Barcelona. I was there working with MapReduce, the first versions of MapReduce. Then working with Solar, Storm, and then I moved to Schibsted, my current company, that we were working at the beginning with SQL pipelines that lucky we moved faster to Apache Spark and then Scala Spark. Also, we have some Luigi. Well, we orchestrated all the Spark pipelines with Luigi and Python tool from Spotify. And then we also have some Jupyter, Elastic, Kafka, and recently we developed a Presto solution to solve the gap between human and data with SQL. No, as you know, not everyone knows Spark. There's a lot of people with product analysts, business analysts, behaviors that they are only familiar with SQL, so we provide the solution. And then next week, this Monday, I will start in a new company, Alpha. It's a health innovation company where I will be working as a data engineer in the data platform team. Now say that, let's move to the talk, how to modularize the Spark code into pieces. Here, after this talk, you will learn how we simplified our code into pieces, how we were increasing our test coverage by using the Spark testing-based library provided by Holden Karau. I don't know if he's here. I hope that no, but no, I don't want to be ashamed. And then how we reduce the test time execution by skipping unaffected code. That at the end implies less coffees. So first point, how to simplify our code. Before going further, I would like to ask here, how many of you have code Spark jobs with more than 1,000 lines? Anyone here played with that? That's a lot of people. Also, how many of you just copy-paste readers between different Spark jobs? No, you're reading data, no, some of you. So you start developing a Spark job and you say, okay, I want to read user behavior data. And then some weeks later, you say, oh, I need to read again user behavior data. Let's come back to the previous job, copy-paste all this code, and then put in here. Oh, that's awesome. No, it's not awesome. So please, don't play with duplicated code, never and ever. No, so it's quite common that we end not just copy-pasting readers, also some transform logic where we play with the data frames. And at the end, when we discover some bug, we just need to come back to different Spark jobs that we also have it, and then this bug is spread across all our code and different repos and different places. So the idea is to try to avoid these cases. How we did that, we start figuring out how we can fragment our code. No? At the end, all the Spark jobs, or more or less all of them, they have readers, they have some transformations. No? Here we can see some aliases, some joins, formatters, different things that at the end transform the data frames. Then we have some context when we have all together, and then we have to write all the data. No? So we start focusing on the readers part. Here, what we end up having is we enforce the schemas. No? As you know, you can read data, and Spark will infer the schema for you, like reading the first 1,000 rows, more or less. However, if you want, you can enforce the schema being type safe, and also if you are reading Spark or ORC, some columnar formats, you will skip the data that you want to read. Now imagine having a data set of 100 fields and you only want to read 3. If you enforce the schema, you are only going to read these 3 fields. That means less data, less network usage, and faster pipelines. No? Also, we provide readers per dataset, and we put inside the source. No? So if you are reading from, imagine you are using Amazon, and you are reading from S3, if you put all together inside the reader, then you avoid worrying about which is the data source from this dataset. And then, as you know, GDPR, no? I don't know how many of you are familiar with the GDPR since we are in Europe, but GDPR was enforced by law this year. It was a lot of nightmares for data engineers. And if you provide readers and writers that are already compliant with the GDPR, then it will be less nightmares or problems with your people. No? Not only the data engineers, but also the data scientists that are going to use your data. So here I would like to show some examples. I will go iterating over this to end up with just one line. That is what the data scientist or the people that is going to read this data can use it. Here you can see that we have a schema. I just put the interrogants to avoid having multiple lines in this. But then we have one path. No? As I said, we are using Amazon to store all the data. So I want to read user behavior data. I have the partitions, year, month, day, hour. And at the end, I have this generation partition. That is the GDPR that we are using at Schibsted. Here, the generation, how it works, is that at the end of the day, we collect all the user behavior, user delete requests from people, from all the users from our companies. And then we create another generation. We copy-paste all the data to a new one, removing these users. No? Once this is done, we remove the previous generation. What implies that is that every time that some of our team want to read this data, they need to go to the S3, look for which is the latest partition, the latest generation available, and then change the code. That is quite a pain, no? Because you need to be aware of the latest generation. Then imagine that we have some read builder where we just specify the format, the schema, and the path, and then we just read. If we iterate over here, we can see, okay, let's try to focus on the path. So instead of just hard coding all the path, I want just to provide the base path. The base path is user behavior data. Then I want to just say, okay, the starting date is now, and I want 12 hours of data, the previous 12 hours. So then we provide some path builder that, given a base path, the starting point, and the duration, it generates all the path that we are going to read. Then the same, we have the reader builder with the parquet, the schema, and the path. No? In this example, I'm just skipping all the path generations by providing the path builder. But if we go further, imagine that since we have the path builder and the reader builder, we can just put inside the path builder inside the reader builder, so it's one line less. But what if we end having just this line? No, we encapsulate all this code and we provide to the people a user behavior reader that, giving a starting point and a duration, it provides all the user behavior data as the data frame. No? So given that, you can encapsulate all these reader lines. No? You can test it properly, and then you provide this to your teams or to your people. No? Or maybe if you go further, to an open source, if this is an open data set. This also, maybe we can extend it. No? As I said before, no? You can specify the schema. Here, maybe we can have some schema by default, but if you want to open it, maybe you can say, okay, if you want more fields, just specify the schema that you're going to read. No? Here, what you will learn? You will learn copy-pasting just one line instead of all the 10 lines or 15 lines across the code. Also, this line is tested or should be tested. So it's better not to avoid issues. Then let's talk about transforms. This line is the Scala documentation, the first one. So it's giving a data set, it returns another data set. No? It's a transform. Some magic, I would like to say, happens inside. If we show 2 examples, just basic ones, we have with reading that giving a data frame, it's adding hello world inside it. No? I will using data frames. I know that I say that it's data set, but as you know, data frame is just a data set of rows, so it's easier just to have like that. And then we have the extract from JSON. Extract from JSON, giving an input column, an output column, and another schema. Then it extracts from a field that it contains a string of JSONs. No, it extracts a schema. Here you could say, well, I can copy-paste this data frame with column, output column from JSON in my logic code. I would say yes, but this function is not dependent of the data frame. So you can test it like this. No, you can test this function properly, and then you can use it wherever you need. If we go further, and I show here an example from our team, the same about the user behavior data. No, as I said, Schibsted owns different marketplaces, and we are collecting all the user behavior to provide better products. So imagine that we have 3 transformations. We want only the classify ads. In this case, is filtering, where the event type is a view and the object type is a classify ad. Then we want to drop duplicates because sometimes when we are receiving events, it happens that there are duplicated events. And then maybe we want to do some analysis for the cities, and we just extract. No, we have some DVDF to extract from an object location address the city. No, then we have a sequence on all these transformations. We stack up all of them, drop duplicate, clean city, and then we have the only classify ads. Then we just use the reader that before, and then we apply all the transforms together, no, in a sequence base. So what happens if instead of just coding all the transformations, we provide them as a library? No? So then our people go there and say, okay, which transformations are already available there? Oh, I have these 3. I can drop duplicated because it's already done and it's already tested, so it will work properly. Then I have clean city that extracts the city from the address, and then I have only classify ads. So then I read the data and then I transform. So imagine the transformations like ingredients. No? As a data engineer, we provide these transformations, ingredients, and then the data scientist, they only need to cook with the proper ones. No? Here, I would like to share some really good work that was our inspiration. I don't know if you're familiar with Spark Daria. It's a really good library developed by Matthew Powers. This guy was, well, the articles that I'm sharing, they were the inspiration of us to start trying to use transformation and trying to modularize our code, because at the beginning we have like a really long methods or Spar jobs with all the logic there, that it was okay at this column, at this filter, all together, pum, 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 pum. And using transforms help us to have better test coverage and better code quality. These 2 articles are really great. The first one, it explains how to chain different transformations, and the second one, it helps you to understand why it's better to provide transformations that are schema independent. No? So it's like, it's not that you need to have this column, it's that you can provide which column are you going to use this transformation, like the from JSON that I explained before. Okay, this is how we split the code with the readers, writers, and the transforms. If we focus now in how we increase our test coverage, no, by using the Spark testing base library. How many of you are already using it here? Okay, only small. The other ones are not testing the code? No? Okay, that's bad for you. So that's what happens. No, if you put untested code in production. I don't know if you're familiar with the Mars orbiter, that in 1999 it was destroyed for mixing up the metric system. No, it was mixing miles with the standard system, and then it broke. So don't try to put things into production without testing. Maybe sometimes this is because we don't have the right tools for testing, or it's difficult for us. So we start using the Holden Karau library. Here, the one thing that is quite good is the shared Spar Context. It has one feature that allows you to share the Spar Context. Maybe the The context is what takes more time to execute when you are testing. So by sharing this across all your tests, then it's better. Now, in our team, we start using this library. However, I will show later, there is one property that you need to override to activate this, the shared thing. And we were like executing tests, and it was taking 30 minutes to execute. And it was, wow, we are sharing the context, why is it taking too long? And then, I will show it, we realized one thing, and then it takes 5 minutes only. So it was a really big change. You need to read the documentation when you use third-party libraries. However, you end up misusing it. And then I will show how to provide some methods. Also, I explained Spar Daria. Here, the Matthew Power also provide a really good library for testing. It's called Spar Fast Test. It's quite faster than a Spar testing base. However, it doesn't support Spark streaming. So if you are planning to use Spark streaming or to test it, don't use it. Just keep the first one. But you can just take a look if you want. Then this class is the code from Holden Karau. It's just the shared Spar context is a trait. And as you can see, it has a variable that is reuse context if it's possible. By default, it's false. So by default, you are not going to share. So what you need to do is you need to extend from DataFrame Suite base. This DataFrame Suite base is already provided by the library and is extending from the shared context. And you need to override this variable to true. Just that. Just changing this, it changed from taking 30 minutes to take 5 minutes in our test because we weren't sharing the context. Then, as a recommendation, you should provide some features, some things. Also here, don't copy-paste it between different test suites. Try to provide it as a trait or a class or whatever. So we have create data frames given a sequence of rows and a schema or JSON fixture to data frame. So you have some JSON fixtures that you want to use as an input and then or to check as an output. So if you provide these features easier, then your people will complain less when they have to develop tests. And then maybe some check schemas. Sometimes the schemas are unsorted, so if you want to check it directly, they are going to fail. So we provide this just to check schemas that are where we don't care about if they are sorted or not. So if you start on the first, if you transform your code into pieces and then you test each pieces separately, then it will be easier to test. And then when you want to put all together in the same place, then it will be easier to build pipelines because everything is tested properly. So when you put all together, then it's better. And then final point is how we skip tests that weren't affected by changes. That is a really good improvement. And also implies at the end less coffees because 30 minutes or 5 minutes maybe is our case. I don't know if any of you here are waiting more than that. Sometimes if you have a long integration test, it can be quite boring or waiting there to end execution. So how we reduce the test execution? Just by using the GUnit for Git. I don't know if anyone is familiar with that library. It was developed by one of our colleagues from Schibsted, Raquel Pau. It's a really great extension for GUnit. What it does, it checks for each, it's an agent, and it checks for each test which classes is loading. So then it stores some annotation, Git annotations, that it says, okay, for this test, these classes were used. Then the next time that you execute, it checks which classes were changed, and then it applies an ignore to the test that doesn't need to be run. How we configure that? If you are using Gradle, you just need to use the test compile, and for this annotation, run with. Then we have the agent. You can add a new configuration, so you avoid to importing this to the full jar, and then you just add it as in the do first. It's just an agent that will run every time that you execute the test. For Travis, imagine that you are using Travis. What you need to do is when you are merging to master and you execute that, you need to push all these Git annotations to the Git. And then in local or in other branches, you will fetch these annotations. So you will compare all the times with master. No? At the end, master is like the truth. So if this test, well, if this code was unchanged, then I don't need to run it because I know that everything is fine. If we, well, I'm supposing here that master is perfect and is not broken. And finally, we provide like 2 traits. No, the normal one, the one that is already everyone using, the one with GUnit runner, and then the one for integration test, that is the Scala Git runner. This one is the one that we are going to use for this test that we want to skip. Then here is more or less the flow. So how it works is when JVM starts the test, it adds this listener that is checking all the classes that are being loaded for its test. Then it stores it, and then the next time it will try to check if, which classes were affected. So this is an example of how it looks. We have, I already run the test, and you can see here all the classes that were loaded. We have the test, context suite, then we have the method, if you are using a suite base, and then you have the context suite, the SPT common bucket, context, configure with params, different things. And then if you go to the log of the test, you can see that we're skipped. So this, well, we were already in 5 minutes. That was, then we end with 3 minutes. Maybe that depends on how many integration tests you are running, but at least at the end, all the minutes are less money that you spend, in resources or in your time. Finally, here for reducing test execution, I recommend the slides from Raquel Pau. She was doing a talk in other conferences, so it's the first link. If you want to know more, please go there and see properly her slides. And then this article, The Rise of Test Impact Analysis. This is the article that inspired her to provide this extension. And then, just to wrap up, use transforms as appeals. Don't duplicate code between Spar shops. You know why. By modularizing all your code. And then don't be afraid of testing everything. There were only a few hands that about test. So please, everyone should be raising the hand because it's good to test. Just the last point. Try to share all you build, all the transformation, all the reader, as a library to your team, or other teams, or if you go further, as I said before, to the community as an open source. So at the end, if everything is well built into pieces, you can end building this Lego castle that looks amazing, but it's because every piece is well done. So thank you, everyone. And if you have any questions, just go ahead.
Thank you, Albert. Any questions for Albert? It's close.
Hi, great presentation.
Thank you.
You did mention that you used quite a lot the transform on the DataFrame. Did you actually performance test your Spark jobs? And did you see any improvements or any degradation by using that?
We didn't check the performance about using it or not. We hope that the catalyst already worked properly. At the end, it's just functions that maybe not in the Spark, but in the master, in the client, maybe it can take more time because you are calling different functions. But at the end, since the Spark is lazy, it shouldn't affect the performance in the workers. But we didn't test it. It was more about maintenance and scalability for us as a developer than not just for performance.
Albert, another question here.
Yeah?
Question. Thanks for the talk, by the way. When you are testing Spark and you are asserting when the result of your test is a full data frame, how do you check whether the results are correct? Do you just compare a data frame with an expected output, or do you have more sophisticated assertions?
We check just input-output. As I said, you can build some inputs just providing in a hard code base, like rows, sequence of rows, and then you just transform data frame, and then you compare what you are getting for. or you just have some JSON fixtures. If you have some UDFs, maybe then you can check it directly without using data frames.
Actually, I have another question, if that's okay. When you are using the transformations library, did you experience any serialization problems when Spark try to send over to the network? Do you have to be more careful with writing that style of code?
Yeah, I had that question before in another talk. That to be fair, we are having all transformations in an object, so we are not importing extra things. No, as there is the article about being schema independent. It helps quite a lot to understand and how to avoid these serialization problems. Since you are schema independent, you are not importing extra things. No? So you can just have like models like inside an object. If you then depend maybe for external things, I don't know, you need to import some JSON files that you want to configure in your transformations, maybe then you need to take care about what you are putting inside. No? If you have, I don't know, job time, and job time is not well serialized, then maybe you need to provide something. But we didn't have these problems.
Question on that side? Thank you.
Do you also test your data readers when they read from streaming data sources?
No.
No. Okay.
We have all the process right now. We have is batch, but we don't have. We didn't test it. We have some. Well, for the writers, well, it's not well related to your question, but for the writers, we have some mockups that we capture the writer instead of allowing the writer to write in, I don't know, in local file or in S3. We just capture that, so we avoid writing somewhere, and we just check it the data frame that we'll try to write.
Any more questions? It's lunchtime, I suppose. Well, thanks a lot for coming. See you back here at in 1 hour or so. Thank you.
Bon appétit.